Hey, so remember this. The idea is you're a dude in a forest. The entire world has no plants. It used to have plants, and you're trying to bring the plants back. That's the idea. That's what we're prototyping. No further explanation. Time flies, and 20,000 lines of engine boilerplate later. That's not the plan anymore. Welcome back to Game Dev. So just getting straight into things, last time we kind of left off on a cliffhanger. That cliffhanger being that there was no game design. I only had an engine. So the first thing to get hammered out here was the design, because that idea was lacking, to say the least. And it turns out the game design is actually harder than any programming problem that I've had in the last 3 months. I've written plenty of games and plenty of engines, but never really tried to branch out and make my own thing, so that ended up being very tough for me. This, of course, isn't helped by my very nebulous ideas about what a design process looked like, which for me ended up just being trying to study a bit about game design, about what makes a game good, playing a bunch of different games for inspiration, looking around at a bunch of different media sources, and writing everything I possibly could down in my notebook. This was, of course, accompanied by prototyping in parallel with the game design, which included transitioning the engine to isometric, transitioning it back to not being isometric, trying to add these little cute things in here, making the main character to a ghost, looking at block placing and how menus would look and stuff like that, and, well, it was kind of just a mess this whole first month. There was plenty of progress on the engine in terms of code maturity, but nothing that was going to actually reach anything that looked like gameplay. So after a month of mental struggle, you might be wondering, where are we at? What is the game that's being designed here? And I'm proud to present, reading directly off of my page of hastily scrawled notes here where the idea came out. It's a game about a robot that loves plants. Oh, and it's also set underground. Like in some caves, I mean. Very important. But basically the gameplay will consist of wandering around caves to find new seeds, developing new plants of your own, and eventually leading to an endgame stage through the development of this whole ecosystem that you've cultivated. It's a little vague and also a little out there, but honestly, after having looked at and played so many different games when I was trying to study up on my game design for this, I wanted to just make sure that I was making something different and original, so I hope it works out. At the very least, I can be pretty sure that it's not just going to be looked at as a clone of another game. Anyway, working and potential final title is Robotanist, because of course it's a robot botanist. Important note as well here with this design is that I didn't really have an idea finalized until about a month and a half ago, so a lot of this engine programming was me kind of just flying blind and prototyping different things. All that said though, let's move on to what everyone is here for, the game programming. So as you can imagine, with 3 months of engine development, there have been a lot of changes in the code, so we're going to be skipping a lot of the nitty-gritty details and just kind of focusing on the most interesting parts. And the first thing to look at here will actually be one of my first prototypes. After transitioning the engine to an isometric view, I kind of wanted to get a feel for how the 3D tiles would look and feel, so I made this block select experiment and I got these icons rendering automatically from 3D. This is a little more complicated than you might expect because it involves asking the GPU for texture data from something that you've rendered so that you can put it back into a texture, which you then send again back to the GPU and then use as a texture. Check out the overview of just some of the code here. And now we also have this fancy isometric view, which quite literally adds extra layers of depth to the game. Next thing up on my big list of early engine experiments was twofold. First of all, adding this little cute guy, just a little entity tester. And then as you can see here, adding in basic translucency. Again, a more complex problem than you might actually expect. If you recall from my first video on this engine, it uses a technique called deferred rendering, where basically only the pixels that are shown on the screen actually get lighting and other effects applied to them. This is done by rendering normal color and depth data, along with other things, into buffers which are then later used in lighting calculations. This is all well and good until transparent objects are added and suddenly multiple pixels need to be lit and blended together. I chose to implement this in sort of a cheaty way designed specifically to suit my needs, by duplicating all the deferred data buffers, rendering and lighting them separately, and then blending everything together again in the final compositing step. It wouldn't be perfect for every game, but for my needs this is absolutely fine. This code would of course later get tweaked and adjusted to make the blending look a little better, but that's a good idea of how it looks. Next thing up was, as per our design idea that we're working with, move everything into the underground. And actually taking a look at the footage of this next milestone I have in my code, this came with a lot of changes actually, so let's break them down individually. Starting with the most obvious from that footage, the new UI elements here. Basically from multiple mockups, and before I had the design of the game fully realized, like I mentioned earlier, I was initially targeting a UI along these lines, and I was able to write some generic UI code to support it in the process. It's basically just a traditional object-oriented hierarchical UI structure, where everything is based off of one root UI type, what I've called UI object in my code. UI objects are then contained and combined in UI containers, which function as lists of multiple objects and allow for the hierarchy. Throw that all under one basic UI root with some cursor logic and stuff like that, and then we've got all this UI code. I was also able to add the neat feature of picking up items using the cursor and moving them around, and also this inventory, which was pretty nice. Taking a look at the next most obvious, but maybe not as interesting thing, we have this guy walking around back and forth like a little crazy dude in the middle of the map. This is just a test code of the player character that I was using for pathing and AI testing. Again, wasn't really final on the design yet, so just ignore him. Then next up we have what I think is the most interesting thing here, which is what's up with this lighting. At this point in the design process, I was kind of trying to decide what the game should actually look like, and I decided that it could be really cool if the entire game was rendered and then lit normally, but then in the final step of compositing, everything was palletized down to a 256 color palette. That palette being the Aurora palette, which is one that I found on this lowspec.com website that I thought matched the game's style pretty well. I think it's a pretty interesting effect, which is actually done incredibly easily as the final step of compositing, where basically the final color value is just run through an RGB color space map or a 3D texture that's pre-palletized, so each color gets matched to its closest color in the palette. All we need to do is compute the closest colors at runtime to generate this 3D texture and then sample it during the final compositing step, and then we have our palletized scene. Here's that same scene that we were just looking at with palletization on and off to get an idea of what the effect is actually doing. There are some added complexities that we won't go over here, including dithering with the lighting, but this is the gist of the effect. Personally, I think it gives a lot of much needed style to the graphics. With a bit of a graphical style and the engine moving in the right direction, let's take a look at the next thing I added, another tester entity, just a portal, to see how that entity component system that I described in my last video actually works out in practice. I know a portal sounds a little bit out of left field, but the motivation is that there needs to be some way to get the player between vertical levels in the world, so I thought it could be a good idea to give it a try. First off, we start by defining a new entity type, entity portal, which can spawn portal entities. Taking the special parameter of this entity portal component. This class just contains some basic functions to add the proper components and spawn entities into the world. And kindly ignore this macro, that is not something we need to look at. Please don't smite me, C++ gods, for using a macro. Taking a look at the core itself though, the most important thing is this create function that takes an existing entity which doesn't have any components added to it and adds in all of the components that make up a portal entity, this being basic position, collision, the portal which specifies the type and color of portal, and then a special rendering and light component that are custom to this type of entity. Their fancy voxel shape determined in that rendering component is actually computed mathematically too by this code. Now taking a look at how all of that code works out in practice, you can see that from that really limited amount of code, we have 3D voxel modeled portals that are spitting out particles, giving lighting effects, they have player collision, they have everything. Looking closely at this footage though, you might notice that they are jiggling a bit, and this kind of brings me to one of the largest problems that I've had with this whole isometric pixel art thing, and probably the hardest problem of the last 3 months. Let me explain. So as you probably noticed by now, the game is quite pixelated. This is good, this is part of the art style, but mixing the pixelization with the isometric camera, we start to get a bit of a problem. Basically, imagine this. We're drawing a cube to the screen, here. The camera is up here at the proper angle to make everything look properly isometric. Our cube is, say, 5 voxels by 5 voxels by 5 voxels, or we would ideally have it be 5 pixels by 5 pixels by 5 pixels. On the X and Z axes, this is fine and this works, we see everything, the camera can see all 5 voxels. But again, imagining from the camera's perspective, what happens to the voxels on the Y axis, especially when they move? Because as a consequence of this isometric angle, we can't fit all 5 Y-axis pixels on the screen, some will have to get chopped off. Basically, they get squished down, and this is where the problem comes for the pixels. You can imagine, for example, if this cube has 5 different colors on each of its vertical layers, we might see different colors as the cube moves, not really making sense from the perspective of the camera. I hope that's a sufficient explanation, but you could really just see the effect in action here if we fix the camera and then the player moves towards and away from the camera on the screen. You can see basically that parts of the player model kind of shimmer, and occasionally the head is a little taller than it should be. The textures for dropped items also shimmer a bit, and this will only get worse the more entities that are added to the scene. That jitter effect you could see here was part of an attempt to fix it, but here's the full code that fixes it, and this is how it works. This is an overview of the hack. Well, I actually don't even know if I should call it a hack, but as far as I know, I've never seen anyone else that's done it like this or even tried to do something like this. So anyway, this is how it works. Basically, any entity, any player, item, portal, anything that we might add later, before rendering calls into this compute routed camera function, which takes in the current entity position and then computes a custom projection matrix to render that entity with, that includes a bunch of rounding to make sure that from the isometric perspective, the pixels that are sampled are always the same no matter where the entity moves. And the unique thing here is that the rounding is done twofold. The first step is that we take the current position of the entity and then find out how much it is offset from a screen texel, that is, a pixel that will actually end up appearing on the final rendered image. That way we can round 3D positions to pixel perfect locations to make sure that there isn't any funky rounding going on in between pixels. The problem with this though, and the second step in this process, is that it creates that jitter that you saw before. That's because this sort of rounding, when applied to every entity on the screen, doesn't make sure that the entities actually align with each other or their real world position, it just snaps them to the nearest texel. So what we do again is we use the new projection matrix that we've created for texel rounding and then see how many pixels it would offset the entity by, and then set the projection matrix back by the opposite of those pixels here. It's maybe not the best strategy, but I have found no other solutions for this and it works. So this is what we're rolling with, and it fixes everything. Including this update too, as you can see, were some test shiny ore tiles to test out new voxel modeling as well, but everything looks good, nothing's jittering around anymore. Except for diagonal movement. Don't look too close at diagonal movement and the pixel jitter there. We're gonna follow this in chronological order, but that's something I fixed like a month later. So just put a pin in that. Just admire the voxel models and all of the nice lights and pretty shiny things on the screen. Speaking of voxel models, the next thing to get figured out for the engine was loading arbitrary voxel models, because up until this point I'd just been doing them in code, and that's all fine, well and good, but for more complex things I might want to crack open Magical Voxel or something like that and design my own models. And I'm not going to be throwing up like the, wrote my own voxel modeler and loader in 48 hours, no game engine, C, Minecraft mod or anything like that. I'm just using a library for this. It's from Open Game Tools, Voxels. The integration code was super simple. I just throw it into my greedy mesher after everything is loaded, and that's it. As a test model, I just slapped something random on top of the player's head, and everything looks good, works. But now, remember earlier when I said that I didn't really have the design finalized until later in the process? Yeah, that later in the process point, that was right here. So now I could finally actually start working on some gameplay. One last very important graphical thing though was getting shadow casting working, because if you take a look at all of the lights in this scene, while it looks nice, there are no proper shadows here. So something needed to be done about that. After brainstorming for a while about different ways to apply shadows to this scene, I ended up with 3 different potential solutions. The first would be to do traditional cube map shadows and then limit the number of lights that could cast shadows in the scene, which is really important because just in this test with light emitting particles, there are already about 100 lights. The second option, and what I already had implemented here, was Minecraft style light propagation and not actually shadows. But that obviously didn't look so good and needed to be changed out. The third idea was, well, a little crazy, but I thought, why not just ray trace all the shadows? I mean, the game runs at a low enough resolution that I might be able to pull it off with reasonable performance, so this is what I decided to try. So step 1 for this was to find out, what are we even ray tracing through? And I thought the easiest way to do this would be to do simple voxel ray tracing through a 3D texture that represents the environment around the current camera location. So this started out by introducing a new occlusion map type to keep track of which voxels are present around the camera. This is updated every frame by iterating over the entire area around the camera and checking to see which voxels have any empty neighbors, that is, they're visible. This data is then uploaded in the form of a 3D texture to the GPU where it can be used by shaders. Using the data from the occlusion map, we can then introduce a basic voxel raycasting function that takes an origin and a direction and then tries to cast a ray through the uploaded occlusion map and see if it hits anything. If it does, it returns true, otherwise it returns false. The sampling here of the voxel data is done through this OCCM sample function, which takes in a world position and then will calculate if there is a voxel at that position. This is done by taking the position, transforming it into texture or occlusion map space, and then just sampling it. And that's really all there is to it. The raycasting, or the hard part, was done. This is then just implemented into the regular lighting calculations for each pixel, where the lighting calculation for any light will just stop if the raycast hits something. Giving this a try for the first time, I was a little bit nervous for the performance implications of the raycasting, but it looks good and it runs well. You can say that I was pretty pleased with how the test worked out. I think it looks super cool, and it's much better than what I had before. Oh, and pause that. I guess it's about time I introduce our main character. This is the robot botanist. Early stages of design, of course, but I think he's cute enough. Anyway, using our fancy new main character, I played around with the lighting a bit just to stress test it and make sure that everything was going to work out. One other thing to notice here that might not even come through due to YouTube's compression is that the top of the scene is now occluded. So using the same sort of occlusion map and raycasting technique, we can make it so that the tops of tiles that aren't really visible to the player can't be seen and just slowly fade out into black. This is a really nice and just sort of subtle detail that should be there, I think. Anyway, with that last graphical adjustment out of the way, it was time to finally start working on something that might resemble, eventually, a game. Not just an engine. The first step here being designing a new UI that's actually going to fit the style of game being made. This started naturally with some mock-ups of the full UI, as I'd done before. And then using the UI framework that I'd written earlier, these were all pretty quick to implement once I got the sprites out of the way. With the UI out of the way and the graphical style kind of coming together, I wanted to add one of the first actual plants into the game. Dandelions, which seemed like a good starter plant, I think, and something the robot will like. This starts out by introducing a new sprite sheet into the game that we can base the model off of, then feeding these sprites into the voxel gritty mesher, doing some matrix math for positioning for the flowers, and we have something that's starting to look a little bit like a dandelion. It's a little bit dark and maybe a little bit hard to identify, but that's hopefully something that I'm going to be working on later as the graphical style starts to take shape. With some actual flowers in the game though, there were a few things that still needed to be polished up. First, by making it so that the new entities that you can now see can get highlighted and there are fades on those highlights, everything looks kind of nice. Then next up, using the exact same fading technique, helper code seen here for the UI. This is that nice fades for the new labels that will show whatever the mouse cursor is hovering over. You can see when we hover over the dandelions, they're just question marks, and that's because the player hasn't discovered them yet. Oh, and there are also a couple of other things here worth mentioning. There's this new tile, which is a sun crystal, because of course, plants, they need sun. There's no sun underground. So naturally, it comes in crystal form, obviously, when you're underground. And also, the robot player got a little blinker on top of its head, which is pretty cute, I think, and will be used hopefully to give the robot a little more emotion and visual feedback. Right now, it's just blinking green to show that the little dude here is still alive and still chugging along. And you might have noticed from the way that the camera was moving in that clip, around this time I was also attempting some sort of soft camera follow mechanism, which it turns out doesn't really work in pixel art games, so that was the next big problem for me to tackle. So what we want is, as opposed to this fixed camera that we have been using, a camera that will kind of slowly follow the player around and interpolate to the player's position as the player moves around in the world. In most games this is easy because you can't just see whole pixels, but in pixel art games that are trying to stay on a true pixel grid, which, like this one that I'm making, you can't do per pixel movement without having it feel super choppy. Around the time I was having this problem, I saw, I think the way you say the channel name is Artificial's game dev vlog about a very similar problem that he was having, so I tried to apply that technique, and this is basically how it works. So in order to get the sub-pixel offsets that we need for smooth camera motion, what we do now is instead of rendering just the pixels that are shown on screen, we render about 2 pixels of overscan on every side of the frame that doesn't end up actually getting shown. This way, now we can start tracking the camera position as a decimal or floating point number and then using the fractional part of this number as an offset into that overscan. Using this simple technique, we just need to adjust the final compositing a little bit, and now we have our problem solved. Perfect pixels on the screen and a camera that moves smoothly. And well, that's pretty much as far as I've reached in this development cycle. I've also done some smaller changes such as sound and some overhauls inside of the codebase with the entity interaction system and everything, but those aren't so interesting to explore, I think, and I gotta leave some stuff for the next devlog, right? And so as always, thank you very much for watching. My Twitter, my VimRC, the theme that I'm using, and a few other things are linked down in the description. And I'll see you next time, where we can finally use the fancy custom engine to actually introduce some gameplay.